In Algebra 2, Section 5.1, we're doing a quick recap on operations with polynomials. So basically, these are the rules for our polynomials and the rules for like when we're multiplying with the same base, dividing, so on and so forth. This is in your book. So I want you to just pause real quick and let's write this down. And then we're going to apply each of these to combination of problems. Okay? So let's just go over them real quick. The product of powers is basically when I'm multiplying two numbers with the same base. Again, they have to have the same base. And if they're exponents, they're being multiplied, you add the exponents. So 3 squared times 3 to the 4th will be 3 to the 2 plus 4, which would be 3 to the 6. And of course, you can put that in your calculator, 3 to the 6. Now, when I'm dividing, I do the opposite. If I'm adding here, I'm going to subtract. So this would be 9, and it's always the top minus the bottom. 5 minus 2, which would give me 9 to the 3rd. Now, let's say you end up with a negative number here, right? Let's say the 2 is on the top and the negative. Well, if you end up with a negative number, then that just means that it's on the wrong side of the fraction. So if I have a number with a negative exponent, that means that I'm going to put it on the bottom of the fraction. Now, see how once I do that, the negative is no longer there. That's how I get rid of the negative, a negative exponent. Now, if it's a negative exponent on the bottom of the fraction, that just means it's also on the wrong side. So if it's on the bottom and it's negative, that means it belongs on the top. So 1 over b to the negative 7 means that this belongs on top, which is b to the 7. Okay? And that's it. A power of a power means that you're not multiplying two bases. You're taking the power of a number and then you're taking another power to it. If I do that, then I just multiply it. So 3 squared to the power of 4 is 2 times 4, which gives me 3 to the 8. Right? And if I have multiple ones in the parentheses, I'm going to take this and I'm going to distribute it. This is only if 2 is multiplied by, if this is being multiplied together. If it's 2 plus x, it's a whole different deal. Because I can't just distribute the exponent. This is only if they're being multiplied. It's a common mistake that people make. But this is 2 to the 4th and k to the 4th. And 2 times 2 is 4, times 2 is 8, times 2 is 16. So this would be 16k to the 4th. Right? With the negative of a fraction, all I need to do is flip it in order to give it positive. Or I can give it each a to the negative 2 and b to the negative 2. Right? And these negatives, when we on the wrong side, that means this b belongs on top, so b squared, and this a belongs on bottom, a squared. And once I put it in its right spot, the negatives go away. And then we have 7 times 0. Anything to the power of 0 is 1. So 7 to the power of 0 is 1. No matter what the number is, anything to the power of 0 is 1. If you haven't done so, and fill these in. And now we're going to use these to go ahead and solve the problems that are needed. So, okay. So for the first one, they're asking us to simplify these different types. And basically, it's a whole bunch, it's a combination of several of these in one problem. So I can take it by doing the problem each at a time. There's probably parentheses there. Okay, so let's take ones. So for these ones that have actual numbers. So I'm just focusing on the ones that can be changed. For example, a to the negative 3, right? This is this would be 1 over a cubed, right? I'm going to underline it to know that I've addressed it, okay? Same thing with c, right? This would be 1 over c to the 1. This is multiplied. And then a squared, there's nothing I can do about it. And b squared would be to the 4th, there's nothing I can do about it. Now I could put this all in one fraction. I can multiply across, right? Whole numbers I multiply, so this becomes a squared b to the fourth all over a cubed c to the 1. Now, from here, I'm going to see if I could simplify even more. Now, these ones I can't simplify, but this I can. This is the same thing as saying a to the 2 minus 3, okay, and I bring over, sorry, let me put this here. This is a to the 2 minus 3, which equals a to the negative 1, which is 1 over a. So this would be 1 over a times what's this transforms into this, and I have to bring everything over b fourth c1. So in one fraction, this would be b to the fourth over c to the 1, or just c. And this, all this gets simplified to this. Right? That might have been kind of quick because you might still be adjusting to the rules. But basically, I'm just going to analyze, and just like when we're reducing fractions, you're just trying to see if I can, okay, can I reduce more? Can I reduce more? So do what you can first, and then just reduce little by little as you go. Because if you try to reduce everything at once, it's going to be completely overwhelming. This is n to the 2 minus 10, because this is both n. Remember, the bases have to be the same. So this is n to the negative 8. Which means that this negative is telling me this n is on the wrong side, and so I do 1 over n to the positive 8. Okay? Sometimes it's hard to see where, like this one, it doesn't matter where I start first. Like I started here, and then I went here, and then this one, the parentheses kind of forces your hand. So I'm going to take this, and I'm just going to give it to every single term. Okay? So that means I'm going to give it to my 3. I'm going to give it to my a cubed, and I'm going to give it to my 4. So this looks like 3 to the cube, a to the 3 to the power of 2, and then b to the 4th to the power of 2. Right? 3 times 3 is 9, times 3 is 27. And this is a to the power of a power, so this is a 3 times 2, which is 6. And this is b 4 to the power of 2. To the power of 4 to the power of 2, this was b 4 times 2, which is b to the 8. And because these are different bases, I can't reduce, so this is as simplified as it gets. So in your simplified, there should be no negatives and there should be no parentheses. There should be no power of powers or anything like that. Hopefully that makes sense. Go ahead and pause it, write it down. We have a couple more questions left. So these ones are all about combining like terms. Okay? Now, please remember that if I have 2a squared, it's very different than 2 plus a squared. Because this one, according to my rules, I can just distribute, but this one means that I do 2 plus a, 2 plus a. This is a common mistake in a lot of tests, so I have to remind you on that. So if I have a power out here, I can't just distribute to every term, okay? But what I need to do is when two groups, two polynomials are being subtracted from each other, I need to take whatever's in front of the polynomial and I need to distribute it. That's how I get rid of these parentheses. So I'm going to do 2a cubed plus 5a minus 7, and then I'm going to write this, just rewrite it down here, bring it down. And this one I'm going to distribute. So I have negative a cubed minus, negative and a negative makes positive 3a, and a negative 2. Once I get rid of the parentheses, then I just combine my terms. Remember, an a is different from an a cubed, is different from an a squared. I can't combine those, they're not like terms. Let's start with the biggest exponents, a cubed. So 2a minus 1a, I'm going to underline it to show that I've taken care of it. I know some people think that that's just extra work, but when you have 14, numbers to figure out or combine like terms, you need to make sure that you've gotten them all taken care of if you're jumping from one side to another. So 2a cubed minus a cubed gives me just 1a cubed. Okay. I don't have any a squared, so let's move to 5, just a's. So positive 5a, positive 3a's plus 8a, and then negative 7 minus 2 is minus 9. Okay? So the next one is the same thing. I'm going to go ahead and rewrite this whole thing down here. So 4x squared minus 9x plus 3. And I'm going to take this whole thing and distribute it so I can get rid of the parentheses. So positive 2 times 2 is positive 4x squared. Positive 2 times negative 5 is negative 10x. And positive 2 times negative 6 is negative 12. And then from here, I'm going to combine like terms. So it seems the x squared is the biggest, so positive 4x plus 4x will give me a positive 8x squared. Sorry, 4x squared, 4x squared. I don't have, okay, I have an x, negative 9x, negative 10x gives me minus 19x. And then 3 and negative 12 is negative 9. Dun, dun, dun. That's my answer. So go ahead and pause and write this down. Try page 307, numbers 3, 4, 9, and 13. 307, numbers 3, 4, 9, and 13, and I will see you in class.